Imagine a time when nothing existed, no stars, no planets, no life, just a void. Then, in a single, almost unimaginable moment, the universe as we know it was born. The entire cosmos, from the tiniest atoms to the largest galaxies, burst into existence. But how did this happen, and where did it all come from? Today, we're going to explore the most profound question humanity has ever asked. How was the universe formed? In the next we'll take a journey through time and space, starting from the very first moment when everything began, the Big Bang. We'll break down the science, the theories, and the mysteries that still baffle scientists today. So, buckle up, because we're diving into the heart of the universe's creation. What is the Big Bang? Let's start with the basics. The Big Bang is the leading explanation for how the universe began. It wasn't an explosion in the traditional sense, but rather an expansion, a sudden, rapid expansion of space itself. Roughly 13.8 billion years ago, the universe was incredibly hot, dense, and compact, all packed into a singular point called a singularity. This singularity held everything that exists today. Suddenly, in a fraction of a second, this singularity began to expand. This expansion is what scientists call the Big Bang, and as space expanded, it began to cool, allowing energy to convert into particles and eventually atoms. These atoms formed the first elements, mostly hydrogen and helium, and over billions of years, these elements clumped together to form stars, galaxies, and everything we see today. The evidence for the Big Bang. The idea of the Big Bang wasn't just a random guess, it's supported by strong scientific evidence. There are three key pieces of evidence that scientists point to when discussing the Big Bang. The expanding universe. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. Galaxies are moving away from us, and the farther away they are, the faster they're moving. This suggests that the universe is expanding. If we reverse this expansion in time, it points to a moment when everything was incredibly close together, a clear sign that the universe began from a singular point. Cosmic microwave background (CMB) radiation. One of the most convincing pieces of evidence is the CMB radiation. In 1965, scientists Arno Penzias and Robert Wilson detected faint microwave radiation coming from all directions in space. This radiation is the afterglow of the Big Bang, a remnant of the heat from the early universe, now cooled to just above absolute zero. Abundance of light elements. The early universe was hot and dense enough for nuclear fusion to occur, leading to the formation of the lightest elements, hydrogen, helium, and small amounts of lithium. The predicted amounts of these elements match exactly with what we observe in the universe today. These pieces of evidence together form a solid foundation for the Big Bang theory, but the story of the universe's formation doesn't stop there. The first moments of the universe, Planck time. To really understand the beginning, we need to go back to the first tiny fraction of a second after the Big Bang, a period called Planck time. This was the era where all the forces of nature, gravity, electromagnetism, and the nuclear forces were unified into one single force. Physics, as we know it today, cannot fully explain what happened during this time because the energies were so incredibly high. Scientists are still trying to piece together the mystery of this era, but one thing is clear: after this incredibly brief moment, the universe began to expand and cool rapidly. This process is called cosmic inflation. Cosmic inflation, the rapid growth of space. Cosmic inflation was a period of extremely rapid expansion, where the universe grew exponentially in less than a trillionth of a second. To give you an idea of how fast this happened, the universe expanded faster than the speed of light during inflation. But don't worry, this doesn't violate Einstein's theory of relativity. Relativity only restricts the speed of objects within space, not the expansion of space itself. Cosmic inflation explains a lot of the universe's structure today, like why the universe looks so uniform on large scales and how tiny quantum fluctuations in the early universe gave rise to galaxies and clusters of galaxies. The formation of matter, from quarks to atoms. As the universe cooled after inflation, it entered a phase known as the quark epoch. During this time, the universe was filled with tiny particles called quarks and gluons. These quarks would eventually combine to form protons and neutrons, the building blocks of atomic nuclei. It took about 380,000 years for the universe to cool enough for these nuclei to capture electrons and form neutral atoms. This period is called recombination, and it's when the universe became transparent to light for the first time. The light from this time is what we detect today as the cosmic microwave background radiation. The birth of stars and galaxies. Now that we had atoms, the next step in the universe's evolution was the formation of stars and galaxies. Gravity played the crucial role here. Small clumps of hydrogen and helium began to collapse under their own gravity, and as they did, they heated up, eventually igniting nuclear fusion in their cores. This is how the first stars were born. These early stars were massive and lived short lives, exploding in spectacular supernova. These explosions scattered heavier elements like carbon, oxygen, and iron into space elements that would later be used to form planets and, eventually, life. Over time, stars began to cluster together, forming the first galaxies. Our own galaxy, the Milky Way, is just one of hundreds of billions of galaxies in the observable universe. The future of the universe. The story of the universe isn't over. In fact, it's still expanding, and scientists are trying to figure out what the future holds. One possibility is that the universe will continue expanding forever, eventually reaching a state of cold emptiness known as the heat death. Another possibility is that the universe could collapse back in on itself in a process called the Big Crunch, or perhaps we'll see a big rip, where the fabric of space itself tears apart. Dark energy, the mysterious force driving the universe's accelerated expansion, holds the key to answering this question, but we still don't fully understand it. The Big Bang and the formation of the universe is one of the greatest mysteries we've ever uncovered. It's a story that spans billions of years, from the smallest quantum particles to the largest galaxies, and we're still learning more every day. But what's truly fascinating is that this story isn't just about the past, it's about us. Everything we see around us, including ourselves, was once part of that singularity. The atoms in your body were forged in the hearts of stars billions of years ago. As we look up at the stars, we're not just seeing light from distant galaxies, we're looking back in time, witnessing the birth and evolution of the universe itself, and who knows what future discoveries lie ahead. So, next time you wonder about the universe, remember, we're all part of this incredible cosmic journey. If you enjoyed learning about the Big Bang and want to dive deeper into more mysteries of the cosmos, make sure to subscribe and hit the notification bell. We've only just scratched the surface of the universe's wonders.